So in this video, we are going to be looking at another example under call of a vector. So we've looked at two other examples. So if you are just coming across this or you missed those two other examples, kindly check the playlist on engineering analysis and then you'll find a link to those videos and every other one, including that of divergence and gradient. Alright, so this says if b is equals to xz cube I minus 2x square yzj plus 2yz raised to power 4. Okay, so find the nabla cross product of v, or called b, at points 1, -1, and 1. All right, so I think I mentioned it when we were looking at gradient and divergence that some question might not tell you call. They might just give you something like this and then ask you to they'll just tell you to find this. They won't tell you if it is called divergence or gradient. So like I mentioned there, you need to really understand how to differentiate a grad, dive, and then call. Exactly. So, but anyway, if you have been following along, I believe by now you should understand the difference. But just for reference purpose and just as a way of reminder, so if you come across a question and then they ask you to look for something like this. So this is grad. That means they're asking you to look for grad. So I believe you should have shared the formula earlier. So if it is something like this with a dot, so this is dive, and then if you're having something like this, so this is for call. Exactly. So then you should be able to apply the formula for each of them. Exactly. All right. So now let's look at this. Now let's now solve this example that we are having on the screen. So we've already established the fact that this question is under call. So for call, the notation is with the cross product of b, that is equals to. So let's draw the matrix of, so this will be for I, j, and then k. So let me just give it enough space. Okay, so that would be on the first row. So for the second row, we are going to be having partial differential of a partial differential of x, partial differential of a partial differential of y, partial differential of a partial differential of z. Exactly. So then for the third row, that's where we are going to be having the function itself. So for this, we are going to be having x z cube, and then here we are going to be having minus. So another thing you need to pay attention to is make sure you write it with the minus sign when you are writing for the second one. So that will be minus 2 x square y z, and then the last one is 2, which is this 2yz raised to power 4. All right, so now let's calculate. So if you find the value in it, please give the video a thumbs up and click on that like button. So cross product of b so that will be I. So let me just open the square brackets. So if you are dealing with I, we ignore everything here. So that means this and this will multiply each other, and then we'll subtract it from, we'll now subtract the product of this and this from it. So follow the arrow. So we'll be having partial differential of d over y multiplied by 2y z raised to power 4 minus partial differential over partial differential of z multiplied by, so this is multiplying this, minus 2x square yz. So that is for I. So let's go over to j, then minus j. So now that we are dealing with minus j, so we ignore everything on this particular column. So let me open a bracket for it. So this will go ahead and multiply this, and then this with this. Are we good? So that will be partial differential of d over x multiplied by 2y z raised to the power 4. So let me just continue here. Minus over the z, that will be x z raised to the power 3. Okay, so the next one is for k now. So if you are dealing with k, we ignore everything on this particular column. So what we are going to be multiplying is the multiplication of this minus the multiplication of this. Okay, so let's do that. So we'll be having plus k. Let's open our bracket. So that's partial differential over that of dx multiplied by minus 2x squared yz minus d over dy into bracket x z cube. All right, so let's continue. All right, so now let's do this. For this now, if you are to differentiate that with respect to y, so this is the only y we are having there. All right, so that will be, so that will just give us 2z raised to the power 4 minus, so if you should differentiate this now with respect to z, this is the only z we are having, and that will give us 1. So every other thing will remain. So that will be minus 2x squared y. So, and that is it for I. Now, before we just proceed further, so you see that we are having a negative sign here and another negative sign here. So they are multiplying each other, and that automatically is minus times minus, and that will give us plus. So let's just put it here. So let's continue now. The next one, we are moving over to minus j. So let me open my square bracket. So if you are to differentiate this now, we are differentiating with respect to x. Since there is no x here, so everything here is just like having 0. So you can just put it here, 0 minus. Okay, so now let's come over here. We are dealing with z. We are differentiating with respect to z, and this is the only z we are having. That is z cube. So if you differentiate z cube, that will give us 3z squared. So 3z squared, then multiply by this x, which is taken as a constant. So we are going to be having, so let's just 3x z squared. Are we good? So that's it for j. So now let's come over to k. So plus k, and then let me open my square bracket. All right, so let's differentiate this now. We are differentiating with respect to x. So this is the only x that we are having, which is x squared. So if you are to differentiate x squared, that will be 2x. So 2x and then multiply with minus 2 and then y and z. So that will give us minus 4 x, y, and then z. Are we good? So now let's come over here. Now we are differentiating with respect to y. So since there is no y here, everything is just 0. So you can just write minus 0, and then we close it. All right, so let's see. Now the question is saying that at point, we are given a point. So the question said we should look for the call at points. Okay, so this is the point 1, minus 1, and 1. Okay, so that means, so at points 1, minus 1, and 1. So So that means our x is equals to 1, our y is equals to -1, and our z is equals to 1. Are we good? So let's say the question did not give us any points. That means what we just do is, this is our answer will just stop. The only difference is we'll just rewrite it without the 0 and without the 0 here. Are we good? But now we are given at points 1, -1, and 1. All right, so let's do that. So that means will be equals to, so let me just put our I outside. So 2z raised to power 4, so that's 2 times our z is 1, 1 raised to power 4 is 1, that's 1, then plus 2x squared y, so that will be 2 times x squared, that's 1 squared times 1, and then y is -1, so that times -1. So what we're going to be having here is 2 minus 2. Are we good? So that's 2 minus 2, that's for I. So let's move over to j, so that will be minus j. So this is 0 already, so let's just ignore it, there's no need to write it again. So we are having -3 multiplied by x is 1, and then z squared, which is 1, and that's 1 squared multiplied by 1. So this is going to be -3, and that is it for j. So let's move over to k, so plus k. So for k now we are having -4 xyz. So x is 1, so that's 4 times 1, times y is -1, and then z is 1 times 1. So we are having -4 times 1, which is -4, multiplied by -1 times 1. So that will give us 4. So let's close it. Okay, so we're already close to our answer. Okay, so the call of B will be, so this 2 minus 2, that's 0, so this cancels out. Then minus j times -3, that will just give us 3j. And then k multiplied by 4, that will be plus 4k. And this is this answer to the question. So that's what we are going to get for the call of this particular function. So guys, I hope you find value in this. If you do, please give the video a thumbs up. Make sure you like and share the video. So this is example 3. We still have one more example. Is it 1 or 2 under call? So we still have one more example we are going to be looking at under call, and that will be in the next video. See you there.